Now I'm going to be taking a look at how to solve for parts of the function algebraically. So, the first one is it says with a vertex of 0 and -9 and passing through the points of -4 and 7. Well, the coordinates of my vertex are always going to represent my P and my Q. Any other point the graph goes through is going to represent a possible point for X and Y. And in this case, I'm missing my A value. So I'm going to fill in everything that I know and then solve for A. So I could say that if I have 7 as my Y is equal to A bracket, my X I'm going to use at -4 minus 0 for P squared plus Q, or if Q is -9, minus 9. This is going to give me 7 is equal to -4 minus 0 is going to be -4 squared minus 9. I'm going to square the -4, which is going to give me 16 A's, and I'm going to add the 9 to both sides to cancel it out. 7 plus 9 is going to give me 16, which means that 1 is going to equal A. If I have an A value of 1 and I have a P value of 0, I can state that Y is equal to, I don't need to write the 1 for A, and I don't need to use the brackets because P is 0, X squared minus 9. And there's my equation. For the second example, I have a vertex, there's my P, there's my Q. I have a y-intercept of 2, and we know that y-intercept is always when x equals 0, which means that I actually have a point or a coordinate of 0 and 2 that the graph is going to run through, and that's my x and y. So I can state that 2 is equal to a bracket x is 0 minus -1 is going to become plus 1 squared and then plus 4 for the q value. I'm going to simplify. 2 is equal to 0 plus 1 is 1 squared is just going to be a plus 4, and I'm going to isolate a. -2 is equal to a. Then I can state that my equation is going to be y is equal to a is -2 bracket x plus 1 for p squared plus 4. Example C. With a maximum value of 12 and x-intercepts at 3 and 15. Well, a maximum or minimum value is always going to represent my q value. The x-intercepts are possible coordinates for the graph to go through. And the other thing that I consider is that if I have my quadratic, it has x-intercepts at 3 and 15 and a maximum at 12, it's going to expand out from that maximum evenly from the axis of symmetry. That's why it's symmetrical, which means that the distance here has to be the same as the distance here. So the p value is going to be halfway between the two intercepts every single time. It's always halfway between. So I need to take the average of those two to solve for what p is going to be. So I can say that my p-value is going to be the average, or the two intercepts added together and divided by 2. And I wind up with a p-value of 9. Now I can solve for what my a value would be using one of the intercept points. I'm probably going to use the point with the smaller number. So I can say that y is 0 is equal to a bracket, p is 9, so x minus 9 squared. And in this case, we decided to use the 3 for x, plus q, which is going to be 12. I can subtract 12 from both sides to isolate it, and I'm going to say that 3 minus 9 is going to be negative 6 squared. Negative 12 is going to be equal to negative 6 times negative 6 is going to be 36a, which means that a is going to equal negative 12 over 36, which can get reduced down to negative 1 over 3. And my equation is going to be y is equal to negative 1 over 3 bracket x minus 9 squared plus 12. Example D is a little trickier. For example D, we have a y-intercept of 20, so I have the point of 0 and 20 that the graph goes through. I have the axis of symmetry is equal to 3, or x equals 3, which means that p is going to equal 3. And I have a point that it passes through, 2 and 4, which means that I have two sets of points that it goes through, and I have the x value at the vertex, but I'm missing both my p value, my q value and my a value. So I'm going to say that this can be x1 and y1, this can be x2 and y2. And I'm going to use them to create a system of equations. I'm going to have the first possibility is it runs through the point of 0 and 20. So I'm going to state that 20 is equal to a bracket x is 0 minus p, which is going to be 3 squared plus q. My second equation is going to use the other point. 4 is equal to a, x is going to be 2 minus 3 squared plus q. And we're going to simplify both these equations. So I'm going to leave the 20 the same, but I'm going to solve for the 0 minus 3 squared. 0 minus 3 squared is going to give me 9, so I have 9 a's plus q. On the bottom, I leave the 4 the same, and 2 minus 3 is going to be negative 1, squared is just going to be 1, so I can call that 1a, or just a, plus q. Now I'm going to solve this system through elimination. I'm going to eliminate or subtract vertically to cancel out the variable q. So I'm going to say that 20 minus 4 is going to leave me with 16 is equal to 9a minus 1a is leaving me with 8 a's. And the q minus q is going to eliminate q. Now I can state that 16 divided by 8, a is going to equal 2. I can substitute the value of a into one of these equations in order to solve what q is going to be. So I can state that 4 is equal to, now we know that a is 2, plus q. I'm going to subtract the 2 from both sides, and 2 is equal to q. I have my q, I have my a, I have my p. My equation is going to be y is equal to 2 bracket x minus 3 squared plus 2. Finally, when we're finding the equation of quadratic functions given its graph, we're going to use the exact same skills we used in the last page. We're just going to look at the graph to find the points for ourselves. So, I'm going to start by finding the key points. I have my vertex is at the point of -3 and 0. I might even label it as my vertex with V. That's my P and my Q values. Then I'm going to pick another point that it clearly shows the graph goes through, in this case -1 and -2, and there's my x and y values. And I'm going to use this to solve it just like we did on the last page. So I'm going to substitute in y becomes -2 is equal to a bracket x is going to become -1 minus -3 is going to be plus 3 inside the brackets, and then if q is 0, I'm just going to leave it out. I could say the plus 0, but that's redundant. I don't need to state the plus 0. So, -2 is equal to a and then -1 plus 3, 2 squared. -2 is going to equal 4a, which means that a is going to equal -2 over 4 or -1 over 2. And I can state what my equation is. Y is equal to -1 over 2 bracket x plus 3 squared, and I'm going to leave the q off because it's just 0. It's redundant. For the next one, I have a vertex at the point of 2 and 1. I have another point that it goes through, which is at the point of 3 and 5. I could use this point over here as well. There's my x, my y, my p, my q. And I'm going to state that 1 is equal to I'm going to state that 5 is equal to a bracket 3 minus 2 squared plus 1. Five is equal to 3 minus 2 is just going to be 1. 1 squared is just going to be 1, or a plus 1. And 4 is going to equal a. Which means that y is equal to 4 bracket x minus 2 squared plus 1. And that's it.